Influence of shapes of interfacial area on rate of liquid-liquid extraction reactions. Nimeke La Rajesh, Dharmpal *. Department of Chemical Engineering. National Institute of Technology Raipur. Abstract. Carboxylic acids serve as feedstock for various useful chemicals and have potential applications in various fields in our day-to-day life. Existing conventional production technologies are not eco-friendly as they generate huge amount of hazardous solid waste. Fermentation process is a promising alternative route, although recovery of biotechnologically produced carboxylic acids from fermentation broth is challenging bottleneck. Out of available methods to separate carboxylic acids from the fermented media, reactive extraction, liquid-liquid extraction, is found to be technologically and economically viable. In this work, effect of stirring speed on available surface area of interfacial geometrical shape for liquid-liquid reactions is studied. Since interfacial area between the phases will influence the design of a reactor, so it must be accounted for. Based on the stirring speed, 4 paste zones were classified: slow, medium, fast and very fast, in the Lewis stirred cell. Each zone causes a different geometrical shape and theoretically correlated with rate of reaction, by complex formation, with surface area available for the specific geometrical shape. Keywords: Hada number, interfacial surface area, reactive extraction, liquid-liquid reactions, reactor design. Introduction. In our daily life we encountered variety of chemicals which are derived mostly from chemical and petrochemical roots. 14. Carboxylic acids, Ca, are one of those valuable chemicals which is basically an organic acids. Due to wide spectrum of applications of Ca in various fields. 5. Demand is growing day by day. Moreover, feedstocks or raw materials used in these roots are mostly non-renewable resources which is depleting with alarming rate. Besides, these chemical and petrochemical roots are energy intensive and hazardous. Alternative for these environmental unfriendly chemical processes for the commercial production is fermentation technology. 10,9. Owing to the advancements in recombinant technology, we can produce almost every carboxylic acid through bio route. However, recovery of carboxylic acids from fermentation broth is incredibly challenging. 8. There are different methods being used to recover carboxylic acids from fermentation broth. Conventionally, salt precipitation method is in practice. Recently, chromatographic methods, ion exchange and adsorption, distillation, extraction, and membrane separations, and so forth, had been reported for separation of carboxylic acids from the fermenter. 9, 3 and 13. Some of these methods are energy intensive, few are still at R&D stage and mostly uneconomical. Among all these recovery technologies, extraction, reactive extraction, is reported a promising and viable method. 7. Reactive extraction is often carried out in 2 steps, firstly forward extraction and then second step is backward extraction. 3, 13. There are 2 main studies required to understand the maximum degree of separation and separation rate: equilibrium studies and kinetic studies. In equilibrium studies, we study how much extraction efficiency is achieved by the selected diluents and extractant system along with the effect of operating parameters, like initial acid concentration, extractant concentration, temperature, pH, etc. In kinetic studies, we investigate how the chemical reaction between carboxylic acid and extractant in the diluents phase -H depend on the mass transfer between phases. L.K. Durraiwemi and M.M. Sharma IV proposed a mechanism for finding the reaction regime, classified reactions in 4 types as regime 1, 2, 3 and 4, based on mass transfer theories and other hydrodynamic parameters. HATTA6 proposed a dimensionless number, Hada number, whether the reaction occurring between the liquid-gas or liquid-liquid phase is slow or fast. Based on Hada number, data ET. AL2 have classified the limiting criteria proposed for the identification of reaction regime into 2 zones as shown in Table 1. If Hada number is greater than 1, HA1, the reaction is fast and takes place in film and the surface area is controlling factor and it fall under regime 3 or 4. If the value of Hada number is less than 1, HA1, the reaction is slow and not takes place in film and bulk phase is controlling factor and the reaction falls under regime 1 or 2. For identifying specific reaction regime, the classification was further modified based on other attributes, like initial acid concentration, initial extractant concentration, stirring speed, and phase volume ratio, dependency on rate of reaction. Among all the attributes, we have focused our study on stirring speed because there is a variation of geometrical shape, available surface area for contact between with respective to stirring speed. As such, the interfacial area between the phases will influence the design of a reactor. In this work, 4 paste zones, slow, medium, fast and very fast, was proposed based on stirring speed in the Lewis stirred type cell. Each paste zones resulted a specific geometrical shape. Based on the geometrical shape, available contacting surface areas between are theoretically correlated with the rate of reaction. Conclusion. Separation of biotechnologically produced carboxylic acids from fermenter using reactive extraction involves the complex formation reaction between acid and extractant. In this work, the rate of reaction, liquid-liquid extraction, was theoretically correlated with interfacial area between the aqueous and organic phases and its variations with stirring speed. Based on ranges of stirring speed, 4 paste zones, slow, medium, fast and very fast, were classified in the Lewis type cell. Interfacial surface area of different geometrical shapes follow the order of. Therefore, Hada number, Ha equals 1, rate of reaction is increasing with increasing stirring speed by interfacial area which increase mass transfer coefficient.